So in this section, we're going to talk about the graphs of sine and cosine. Before I actually show you the graph of sine, remember that when you're evaluating the sine of theta, so let's say the sine of theta equals a half. Where is that true? Well, what I'm asking you to identify is what angle is going to give you an output of a half. So your input is your angle, and your output is the point on the unit circle. So essentially what we can do is we can create a function for sine. So let's call it f of x equals the sine of x. Again, your input x is going to be the angle, whether it's in radians, degrees, doesn't matter. And your output f of x or y is going to be the point on the unit circle. So let's go ahead and actually evaluate a quick table of values for that. And let's start off basic. Let's start off with 30 degrees. Okay, let's do 60 degrees. Let's do 90 degrees. Okay. And now I'm going to actually start skipping a little bit. Let's just do pi. Let's do 3 pi over 2 and 2 pi. And let's identify our output, and then we're going to put that on the coordinate plane and see what does that look like. Okay. So this is exactly what we end up with, and I just realized I forgot to include 0 radians or 0 degrees. What is sine at 0 radians or 0 degrees? 0. Okay, so now I have a set of coordinate points that I can graph. Let's go ahead and do that. Remember, x is corresponding to, and I'm only going to create my graph on quadrants 1 and 4. We'll take a look at what happens in quadrants 2 and 3 in just a moment. But let's focus on quadrants 1 and 4 for just a minute. Okay, x again is what's happening, your angle, your input on your angle. So here we have here's pi over 2, here's 3 pi over 2, and here's 2 pi. And in between here, because I jumped, I said, here's your 30 degree, here's your 60 degree, and we can go ahead and we can put those in there. But I kind of want to focus on what's happening at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, that's sufficient to graph this. And notice that you're only going as far up as 1 because we're on the unit circle, and as far down as -1. So your peak here is going to happen at 1, and your dip is going to happen at -1. So 0, 0 is a coordinate point. At pi over 2, you're at 1. At pi, you're back at 0. At 3 pi over 2, you dip down to -1. And at 2 pi, you're back up at 0. This is just one time, we're going to pretend I connected the dots, one time around the unit circle. We know we can continue indefinitely around the unit circle, 2 pi, 4 pi, 6 pi, etc. So you would see this curve continue on and on and on towards the right, towards the positive infinity, and the same in the negative direction because we can go negative rotations on the unit circle. So this is one rotation for the sine curve around the unit circle, and we can go ahead, again, this is going to be 30 degrees, 60 degrees, and I can go in intervals of that if I wanted to, but we can clearly see that it's falling here between 0 and 2 pi. When I make my table, I usually focus on these main points, these 1, 2, 3, 4, 5 points, and then I shift those. Okay. Here it's a little bit more precise. We can see the 30 degree angle here, the 60 degree, the 90 degree, and this is one rotation around the unit circle. Or our period is 2 pi. Remember, period is how long until it starts to recycle. Here is sine with 3 full cycles. So So here I have one cycle, 2 pi, then I have another one at 4 pi, and I can continue if I wanted to. Or I can go in the negative direction, in just like this, towards negative 2 pi. Okay, so let's go over some basic definitions of amplitude and period. Okay, so if we have our given function y equals a sine of bx, the amplitude is going to be the value in front of sine. That's going to determine the height of your maximum and your minimum values. So half the distance between the maximum values of the function is going to be given by the absolute value of a. The period is the complete cycle that's happening. The period is the horizontal distance of one complete cycle. The formula is 2 pi over b, because we can compress the cycle or we can expand that cycle. So it doesn't necessarily have to be exactly 2 pi, it just depends on what's going on with the functions. Think back to those transformations that we did in chapter 1. Alright, so some steps to keep in mind when you're graphing. The first thing you want to do is always identify the amplitude in the period. So if I just write y equals sine of x, clearly your amplitude is 1 and your period is 2 pi, because I'm putting 2 pi over b and 2 pi over 1 because there's nothing in front of x except for 1. So your period is 2 pi. Your amplitude is 1 because that's what's in front of sine. So again, that maximum height is going to be 1. And that dip that's happening is going to be at negative 1. Find the values of x for their 5 key points. Again, I like the quadrantal angles, 0, pi over 2 pi, 3 pi over 2, and 2 pi. If it's being shifted, and we'll talk about that in just a minute, you're going to create the shift to those points. The 3 x-intercepts, the maximum and the minimum points, are happening at those quadrantal angles. Then you want to start with the value of x where the cycle begins, and then you want to add quarter periods. That means you take your period plus a fourth of that period to it. So if your period is no longer 2 pi, let's say your period is pi, then you want to create quarter periods so that way you have those main points to find successive values of x. So that's what we're talking about, those 5 main points. Find the values of y for the 5 key points by valuing the function value of x from step 2, the quarter period. So if your period is 2 pi, then that makes it easy. Your quadrantal angles are the points you're going to be plotting. 0, pi over 2, pi, 3 pi over 2, 2 pi. But if your period switches to, say, pi, and I'll give you an example of that in just a moment, then you want to take quarter periods, and that's going to give you your next 4 points. I'll show you that in just a moment. Then you connect the 5 points with a smooth curve, with a complete cycle. If the instructions add for 2 cycles, you can go either in the positive and negative direction or twice in the positive direction. And that's what step 5 is. Okay, here it says graph y equals 2 sine of x. So the first thing we're going to do is we're going to identify the amplitude. So what is the amplitude here? 2. Then you want to identify your period. Remember, your period is 2 pi over b. B is what's in front of x, and what's in front of x is y. 1, excuse me. So 2 pi over 1, so it's 2 pi. This one makes it easy to graph, because now I'm going to just graph just like I did before with my quadrantal angles. So let's create, if you would like, a table of values. What I'm saying to do is the following. So here's x, here's y. My amplitude is 2. Negative 2 is my dip. And now I'm going to do my quarter periods. So a quarter of 2 pi is pi over 2. And then add successive pi over 2s to get a total of 5 points. That's going to be your quadrantal angles for this. So what I asked you to do was do this, and you end up with pi over 2. That's your quarter period. That's going to give you your next 4 points. So you're going to add pi over 2 successively. So pi over 2 plus pi over 2 is pi, plus pi over 2 is 3 pi over 2, and then plus another pi over 2 is going to be 2 pi. For sine, you always start at the origin, 0, 0, then you go to your maximum, back to your intercept, then you dip, and then you go back to an intercept. This was in the positive direction. The instructions didn't tell us to graph 2 full periods, but in the homework you might see that. So let's go ahead and go in the negative direction so you can see how you would graph an additional cycle. Okay, so I'm going to keep those same quarter periods in the negative direction. I'm just going to put a negative sign in front of them. So that's going to be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then you're just going to continue the pattern. So now we're going to dip instead of peak here, back to an intercept. You're going to peak at the 2, and then you're going to go back to an intercept. So then in the red, you can see a negative period, or an additional period to the left. So here's example number 2. We're identifying our amplitude. This was just like the previous one. There's no change in period here. Your amplitude is happening at this value, 1/2. Your period, remember, that's 2 pi over b. So here I'm putting 2 pi over 1. So your period again is 2 pi. So here we're using those same quadrantal angles. 0, pi over 2, pi, 3 pi over 2. And that's going to be my quarter periods because I'm taking the fourth of that. I get pi over 2 and I'm adding pi over 2 4 times to itself to get those quarter periods. So it's going to look exactly like my previous graph. So it's going to look exactly like the previous graph we just looked at. Here's x, here's y, with the exception of, remember we graphed it at 2, the parent's happening at 1, but now we're reducing that amplitude in half. So that's essentially what's happening right there. We're reducing the amplitude to right here. Again, the parent happens at -1 for your minimum value. The one we just finished graphing had an amplitude at 2, but now we're reducing the amplitude in half. So what we're doing is we're compressing it vertically, okay? Your quarter periods, or your period, is 2 pi. So we're using the quadrantal angles to graph this. So pi over 2, pi, 3 pi over 2, 2 pi. All right, so let's go ahead and graph it. Remember, sine curve starts here at the origin, peaks, intercept, dips, and then it's back at an intercept. So this is one cycle. And I can add a cycle either to the right or to the left. So if I wanted to, let's go to the left. Here's negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And let's go ahead and graph it. You're going to go to a minimum, an intercept, a maximum, an intercept. And here's 2 cycles of the sine curve compressed. Why? We reduce the amplitude in half. Okay, so here we have an example where the amplitude and the period have shifted. Okay, so let's take a look. Remember, you always want to start by identifying the amplitude. The amplitude is what the absolute value of what's happening in front of sine, and that value is 3. That's going to be your maximum and your minimum value. And then you want to identify your period. Remember, your period is 2 pi over b. B is the value that's in front of x. So here we're doing 2 pi over 2. So now your period is pi. That means that the quadrantal angles from the parent, 0, pi over 2 pi, 3 pi over 2, 2 pi, are no longer good. That's going to be 2 cycles for this one. Okay, in fact, I'll actually show you what that looks like in just a moment. So what you want to do from here is find your quarter period. Find your quarter period. How do you do that? You take your period, which is pi, and you divide it by 1/4. That's point number 2, because remember, sine always starts at the origin, unless you shift it to the right or to the left, but we're not there yet. Okay, God bless you. So that means point number 2 starting at pi over 4. Your next point, add pi over 4 to that, you get 2 pi over 4. So this is point 2. I'm going to put point 2 so that way we know. Then we're adding pi over 4 for point number 3. So pi over 4 plus pi over 4 is 2 pi over 4, or pi over 2. This is point number 3. I add another pi over 4 to my 2 pi over 4, so that's going to give me 3 pi over 4. This is point 4. Then I'm going to add another pi over 4 to 3 pi over 4 and 0.5 because you need those 5 key points, right, for one complete cycle. 0.5, 4 pi over 4, 4 pi over 4 is equal to pi. And that is my period length. If I did not finish at my period length for 0.5, I did something wrong. Okay, so let's go ahead and graph it based on the amplitude and those points that we just identified. Okay, again, remember your amplitude is 3. I'm going to graph 2 full periods to the right instead of including a period to the right and to the left this time. So here's our x-axis, here's our y-axis. Our amplitude is happening at 3. So let's say that's 1, 2, 3, -1, -2, -3. All right, so now we need to label those quarter periods. So pi over 4 is where we started. Then our second point, that was our second point. Our third point was pi over 2. Our fourth point is 3 pi over 4. And our 4 point is your period, pi. Remember, sine always starts at the origin, goes to the amplitude at the max, back to an x-intercept, then dips to minimum value, and then back to an x-intercept. Okay, we're going to pretend it's drawn to scale. That's one cycle of the amplitude. Notice this time in comparison to the parent graph, it's been vertically stretched and horizontally compressed because your period has been reduced in half. Let's graph another cycle. So after we're back at the x-intercept, we're going to peak again. Intercept, dip, intercept. We're going to pretend I connected the dots properly there. So that's 2 cycles of the compressed period and this vertically stretched amplitude. The parent would be happening right here. Let's actually go ahead and graph the parent on top of this so you guys can see what would that look like. And I'm going to do that in yellow. So here would be this point. Remember, this is, you can't really see that color. Let's do it in green. So here's 1, -1. You start here, here, then you dip here, here, and then you're back here. So this is, okay, very terrible picture, but in green, that would be the parent. And now you can clearly see it in comparison to the graph's function that it's been compressed and stretched. All right, example number 4 says, determine the amplitude and the period of the following graph and graph the function. So another example, here your period. Let's start with your amplitude. Amplitude is 3, so your maximum minimum are going to happen at 3, -3. Where did I get that? I got that from the value in front of sine. Then you want to identify your period. Your period is 2 pi over b. So we're putting 2 pi over what's in front of x? Pi. Good. So your period here is in terms of 2. So you just switched your period. Now you have to find your quarter periods. This shouldn't be too bad because it's just like your quadrantal angles except pi's missing. So instead of saying pi over 2, you're just going to say half. Instead of saying pi, you're going to say 1. Instead of saying 3 pi over 2, you're going to say 3 over 2. And instead of 2, it's going to be 2 pi. It's going to be 2. So just like the parent, except there's no pi there. So let's go ahead and graph that. Here's your x-axis, your y-axis, your amplitude, a half, 1, 3 over 2, and 2. Again, what I did was I took my period, broke it up into quarters, I got a half, and then I added consecutive a half for my remaining points. So half plus a half is 1, plus a half is 3 over 2, plus a half is 2. And now I can go ahead and graph my sine curve. Remember, you always start at the origin, maximum, intercept, minimum, back to an intercept. That's one cycle. If you want, you can do a cycle to the left and get negative a half. There you would have a dip. And then we can continue this graph at -1, etc. And then you would be back here.